Okay, friends, so let's set up some hypotheses if we can. There's 5 different situations here we'll get into it here. We've learned 2 techniques in class, and if you really want to push it, we could say we've learned 3 techniques in class because we've done matched pair t-testing and then just technically single mean testing, but both of those are single mean testing. So let's just dive in and see what we got here. Number 1 here, it's largely believed the infection rate for a certain disease is 1.2%. All right. Pharmacists believe they've come up with a vaccine that lowers it. Okay, so we're looking for, I'm going to put it down here, little p is going to be equal to the infection rate of those with the vaccine, right? Because that's what we're trying to show. And the hypotheses, H0 and H1, well, H1, they believe they've lowered it, so we think it's going to be lower than that 0.012. And H0, I just said H0, I meant H1. The research hypothesis is the pharmacists claim that they're going to be lowering it. The null is the opposite of that, which is going to be greater than or equal to 0.012. And that's all you can do here. You can't actually test this without me giving you some kind of data. So I'm just going to color that in red, and then we're going to leave it there, and that's going to be the hypotheses for number 1. All right. I'm going to copy the formatting down here to the next one. Statistician wants to see if the rate of homelessness in Bend is different than the rate of homelessness in Portland. There are no known rates of that should be ness, for homelessness for either city. This is one of the ones you can't do. This one you leave blank to get the 2 points. If you wanted extra credit, it's called a 2 independent proportion hypothesis test, because you do up in number 1 you had 1 proportion and you had a known value to compare it against, the 1.2%. Here you've got 2 different proportions, neither of which you know, but you're trying to show that they are either equal or not equal to each other. And again, this is something that if Math 244 ever gets turned into Stat 244Z, we will analyze there. Okay. An educational consultant has created a series of assessments that she believes will raise the average score for a certain skill test. Okay. She gives a pre-test, institute the assessment, and then gives a post-test. Okay, so some clues here. First of all, she thinks she can raise the average. So right away, we know we're dealing with an average, which is mu. I'm going to insert that up here. That's an average. All right, mu, there you are. Okay. Now, it's not going to be an infection rate this time. It's going to be, if we're looking at the difference between a pre-test and a post-test, then the average is going to be the difference between the pre and post tests. Okay? Now, the null is going to play devil's advocate every time, and it's going to say there is no difference. But the researcher, she believes that she's going to increase the score. So I'm going to say that this is mu is greater than 0. And the reason I'm saying mu is greater than 0 is because I'm assuming we're subtracting the post minus the pre. And if we do that and the test is working, that means the post-test score is going to be higher than the pre-test score, so we should get a positive number, and that's what that would be. Which means the null hypothesis is the opposite of that, which is going to be mu is less than or equal to, oops, wrong button, less than or equal to 0. There you go. This is a single mean, but it's also a matched pair test, matched pair. Okay. The average, this is a fun question. I actually thought about this while I was making breakfast last week. Average number of yolks per non-free range chicken egg is 1, which, 1 egg, 1 bird. As an amateur researcher who purchases eggs laid by free-range chickens, I believe the average number of yolks per egg is greater than those by non-organic free-range ones. All right, so I'm going to change that to non-free-range, which hopefully was understood. So the mu we're interested in is studying the free-range chicken yolk numbers. Let me say that less stupidly. Number of free-range chicken yolks per egg. There we go. Makes a little bit more sense. The null hypothesis is, well, actually, the research, my claim is that it is greater than 1 because normal eggs have 1, and the reason I thought it would be greater than 1 is because of all the eggs I cracked last week with my first organic free-range 20-pack of eggs, and it seemed like 2/3 of them had double yolks. So the opposite of that is going to be it's less than or equal to 1. That's pretty straightforward. I gave you, it's an average for sure, the average, and I gave you a number to test it against the 1. So if you're keeping track, you now have been able to identify 3 sets of hypotheses, which means this one you can't. And just so you know, if you read this one, you've got its proportions, because they're all percentages, but there are 6 proportions, not 2. So you can't do this one up here, the 2 independent proportion hypothesis test, because there's 6. There's not 2. And just so you know, there's also not a 6 proportion hypothesis test. There's something called a chi-square goodness of fit test. And this is something we'll also get into in Stat 244Z if and when that puppy dog ever comes on the scene. As far as Googling that stuff, you can just ask it, what hypothesis test do you use for 2 proportions or more than 2 proportions, and it should come up with the answers. All right, my friends, I hope that helped.